Hello, welcome back. So in the previous part, we have seen the classification of force, uh, classification in terms of coplanar, concurrent, and uh, parallel system. Now we will discuss more about it, and now we will see how do we compose and resolve the forces. Now, when we talk about the composition or resolution of the force, now what is actually the meaning of composition and resolution that we will try to understand. Well, in the structural analysis, most of the time we need to add force or we need to subtract forces. So we need to understand how do we add two forces or three forces, or how do we subtract forces from one from the other. So we need to understand how we do that. Now, the process of now force is basically a vector quantity. So sometimes when I say process of vector addition, it is actually the force. So process of force addition is called composition. So when we call composition of the forces, it means we are actually talking about the addition of the force vector or combining the force. We are combining the force. So that is also known as composition. Similarly, when we subtract force, then the process is called resolution of the force. So in that case, what we do is we subtract force or we divide force in two component. So that is called the resolution. Now, when we resolve or when we subtract a force into components, so that component of force, it represents the part of the force but not all, and of the effect of the original force. So if the original force is like this, so we can resolve this force into two component, like in the horizontal and in the vertical component. So we will discuss more about it in the later lecture. Now, as I said, force is a vector quantity. Now, what is the meaning of vector quantity? Well, vector quantity are the quantities which has magnitude as well as the direction or the sense. So basically, I hope you understand, in the physics we have two types of quantity. One is the scalar quantity and the second one is the vector quantity. So in the scalar quantity, uh, the quantity is having magnitude only. It doesn't have the direction. For example, the example, if we take the velocity and speed. So velocity is the vector quantity and speed is the uh, scalar quantity. So this is the vector quantity. So it means velocity will be having magnitude and it will be having the direction. So if a thing is moving a particular direction, in that case, it will be having direction, it will be having proper angle from a reference line, and it will be having a magnitude, say velocity, it may be 36 meter per second, something like that. And but in case of speed, it will be having only the magnitude, but it will not be having any direction. So that is the difference between the scalar and vector quantity. So as I said, force is a vector quantity, which means force will be having magnitude, it will be having direction as well. And because of that, while adding the forces, while subtracting the forces or resolving the forces, we need to take care of magnitude as well as the direction of the force. So now we will see how do we compose or how do we add the forces. So now in this we will say how do we add the forces. So as I said, when adding two vectors together, it is very important to account for both their magnitudes and their direction. So we need to account for that. Now, generally we can add forces using a law which is called parallelogram law of the addition. Now, according to this law, if there are two forces, say one force A and the second force is say B. So what we can do is we can add these force like by making a parallelogram obviously in that case we need to have this direction also. What is the direction between these two forces? That is very much required. So in that case, if we on on this head, say this is the B and this is A. So on the head of the B, along this head, if we make a line, a dotted line, which will be parallel to force A, and similarly from the head of A, if we make a line which will be parallel to B, then you can see the parallelogram is forming, and the resultant of these two forces will be the diagonal of this parallelogram. So this will be the resultant of these two forces. So I can say here R will be equals to A plus B. So that is what I am showing you graphically how it is being happen. Now mathematically we will understand about it more in the next lecture, but for the time being I am just showing you graphically how the resultant, or how the result of two forces, how we can add them. So we can add them using the parallelogram law. So here you can see these are the two forces A and B, and when we join them and if we construct two lines, so the point where it is meeting, so if we join these 2 points, then this becomes the resultant of these two forces. Well, addition of the forces can be done using another method also, which is sometimes called the triangular rule. So we can add two forces using the triangular rule also. And in case of triangular rule, we generally follow a pattern which is called head to tail. So for example, there is two forces again. So what we can do is we will try to make triangle of these two forces. So like this is force A, this is force B. So this is force A, and if I add this force by the tail, I mean the head of A, and it is connected with the tail of B. In that case, the closing side of the triangle, will be the resultant of these two forces. Or I can say I can add AB as, I mean we can add A plus B as R, and even B plus A will also be equals to R, which means uh, in the triangular rule, these forces, the property of commutative is works here. Like I can read here also, like this is B, and if I join this with the A, say this one, this becomes A and this becomes B. In that case also, the resultant which will be forming by them will also be equals to R. So in this I have done A plus B, in this I have done B plus A. So in both case the R will be same, and this property is called the commutative property. Commutative property. Okay. So you can see here the same diagram. So by comparison, as I said, it is seen that vector addition is the commutative. So we can add A plus B or B plus A, both will be equivalent to the R, which is the resultant force. So this is the composition of the forces. Now we will see the resolution of the forces. Now resolution of force is sometimes called force subtraction or vector subtraction. Now in the resolution of force, generally what we do is we can find out the difference of A and B. Now we can write this difference as A minus B is equals to R dash. Okay, so in that case A is the positive force and B is the negative force. So we can write this as A plus minus B is equals to R. So you can see this is A force and say this is B force. So if I have to find out the negative of b, then obviously negative of b will be of the opposite direction. So this I can write as negative of b. So in that case we will add these two forces. So this is actually the special case of the vector addition. So in that case what we are doing is we are adding this a and negative of b. So again you can see the parallelogram will form like this. See in this diagram, this is positive a, this is positive b, and negative of this b will be of opposite direction. So in that case we can form parallelogram like this. And similarly on the same fashion we can subtract using the triangular rule also. So in that case the direction of the force, I mean the sense of the force, is actually opposite. So when we say b, the sense may be like this. When we say negative b, the sense will be opposite to it. So you can see here this is also a special case of vector addition in which we are adding force of opposite sense. So I have written here also, subtraction is therefore defined as a special case of addition. So the rules of vector addition also apply to vector subtraction. So we will discuss more about parallelogram law, triangular construction, more about it in the next lecture. So that is all about, so that's it in this lecture. So I hope you understand the topic well. Thank you.